Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to dwell into the topic notion of an algorithm, which is the very basic and the common thing for the course design and analysis of algorithms. Let's get into the topic, the notion of an algorithm. Before that, we have to know what is an algorithm. So algorithm. So what do we mean by algorithm? An algorithm is a finite sequence of instructions that are to be followed to accomplish a specific or a particular task. So in addition, these algorithms must also satisfy the following criteria as well. So the first criteria being input. So as we all know, input to an algorithm is very important. So an algorithm requires one or more input. The values that are first supplied to the algorithm before its processing, we call them as inputs. So these inputs come from a predetermined range of acceptable values. The next thing is followed by the output. So one or more outputs must be produced by an algorithm. The output is the outcome of the algorithm after each step that has been completed. The relationship between the input and the result should be very clear, and it should also be very effective. The next one is definiteness. Definiteness is the important property of an algorithm. Followed by finiteness, it should end with a finite number of steps. Then comes the effectiveness. So the effectiveness at an algorithm stage must be sufficiently straightforward to be carried out in a finite time utilizing fundamental operations. We have, with the resources at hand, every operation in the algorithm should be doable, and also it should be a practicable thing as well. So let's see the notion of an algorithm. So we all know what is an algorithm, its characteristics. Now we'll see what is definitely the notion of an algorithm. So how the algorithm works also. So as we all know, the first and foremost thing how the algorithm works is come from the input. So algorithm takes input data, which can be in various formats such as numbers, text, images as well. Then processing will be done. So processing, the algorithm processes the input data through a series of logical and mathematical operations, manipulating and transforming it as needed. Output, after all the processing is completely done, the algorithm produces an output which could be a result, a decision, or some meaningful information. So efficiency has to be calculated. A key aspect of algorithm is their efficiency, aiming to accomplish a specific task quickly and with very minimal amount of resources. Optimization, algorithm designers design constantly seeking ways to optimize their algorithms. Implementation, algorithms are implemented in various programming languages, enabling the computers to execute them and produce the desired outcome. So why do we need algorithms? So we require algorithms for different things. So the main and the foremost thing is of two things. One is scalability, the other one is the performance. So it aids scalability, it aids in understanding what is the real world problem and what it is sizable, how we are going to break it into small step, all will come under scalability. And then the performance. So performance, the real world is challenging to break down into the smaller sequence of steps. If a problem can be easily divided into smaller steps, it indicates the problem is much feasible. After understanding what is an algorithm, why we need an algorithm, we can also see the uses of the algorithms as well. So the algorithm is used in many areas like data analysis and machine learning, cryptography and security, information retrieval and search engines, etc. Even it is used for optimization problem, medical diagnosis, everything. So we have seen what is an algorithm, how it is used, what is its characteristics, and we have seen how the notion of what is the notion of an algorithm. Now let's see what are the types of algorithm. So to write an algorithm, there are three different kinds. So first one is Euclid's algorithm. The other one is consecutive integer checking algorithm, middle school procedure, that is the layman procedure. So for example, let us take the Euclid's algorithm for computing GCD of m comma n. So in simple steps, we can say if n is equal to 0, return the value of m as the answer and stop. Otherwise, go to step 2, divide m by n and assign the value of the remainder to r. Assign the values of n to m and the value to r to n. So again, go to step 1. So this can also be used, the same thing can also be used by consecutive integer checking algorithm as well. So consecutive integer algorithm will give the English like language. So assign the values of min n to 1, divide m by t. If the remainder is 0, go to step 3, otherwise go to step 4. So step 3, divide n by t. If the remainder is 0, return t and stop, else go to step 4. Repeat the process, decrease t by 1 and go to step 2. The same thing can also be written by middle school procedure. Find the prime factors of n. Step 2 will be the find the prime factors of n. Step 3, identify all the common factors and then in the prime expansions, then compute the product of the common factor and return it to the greatest divisor of the numbers given. So these are the types how an algorithm, a same algorithm can be written.